Hello, my name is Jacob. I am from the University of Stuttgart, and I'm here to present a work I did together with Jochen Teitzer. He's from the Ruhr University in Bochum, also in Germany, and we were trying to develop a lean production controlling and tracking approach using digital methods that can be used for as many methods, lean methods, as possible. Our research motivation can be described with a quote. The quote has been done by my professor, Professor Werner. He said that the digitization of processes is required, that the technology pretty much exists, and that we only have problems to adapt it, and that problems we have in industry, but also in academics. This is at least true for Germany, probably for some other countries as well. So what we did to develop our approach was we had a look again at lean, at the methodologies that have been developed in lean production, in lean management, in lean construction. It's always good to refresh your knowledge about it to get a new perspective. So we looked at the shipbuilding industry, at Taylor, at Fordison, at Refa, at Deming, Uran, and of course at the Toyota production system. And we realized that, in the stationary industry there's a very long history of applying lean methods. Therefore we can see that there are lots of production systems which are basically standard. Any car manufacturer has a production system with a bundle of standardized methods and tools, and they don't talk about implementing lean, they just do it. It's an absolute standard. In the construction sector, it is quite different. From my perspective, I see only few holistic production system approaches. Earlier on, we had a presentation about one, but that's rather an exception than the standard. Also, what we can see is a little standardization when it comes to method, tools, but also software. Also, we have two prominent production control methods that are discussed widely here in these conferences. Last planner system, tech planning, of course. Those are, I think, the most prominent ones. And location-based management as well. So what we did is, we looked at those methods to identify an approach to develop that controlling method that we are looking for. So we compared last planner and tech planning and tech control, and we realized there are quite a few differences when we look at it. Those methods differ quite a lot, but we also realized that although they work differently, they can be combined together, they can be implemented together, so that we can adapt to the requirements of a certain project. And what we also saw is that we can combine it with further methods. For instance, location-based management or critical chain to implement the theory of constraint of Goldred, or even earned value analysis to get a bigger picture of the project. And what is the common denominator of all those methods, or of the different methods? We had to identify that in order to get the right approach for our controlling system. And there we thought about the three categories of constraints that Glenn Ballard also described. That is directives, prerequisite work, and resources. Those are the constraints of a construction site, and it's always important to have information about that. We need to know which information is required for construction, what work has been completed or needs to be completed, and what resources we want to apply. So the focus was on the information management, dealing with those constraints. So we looked at the data flow that we have in a project, and we found out that in each of those methods we have basically planned data, actual data, and forecast data that needs to be generated in a continuous way. So we have a control loop that allows us to assess the productivity of a project and to plan the next steps. And the singular and combined use of production control methods requires this constant and reliable flow of information, constantly, to assess work progress, constraints, and productivity. And we also found out that the building information model is the enabler to do so. The building information model is the place where we store the data, we update it, where we make information available. That's why we came up with this approach. Here we see the control loop, and at the bottom we see the building information model environment. We plan the project, we have the resources, the processes in our database, we plan the topology, meaning that we know at what place of a building or a construction size will be done what work, and all that gets combined in a construction schedule, and that construction schedule assures us a precise space allocation and work allocation, so that the trades can do their tasks, they have their instructions, and they know in what time they have to do it. But very crucial is now to get an update, a feedback from the building side, and for that we obviously use modern technology, a mobile device, just a smartphone, where the people can enter whether they completed a task, we can track the position of the worker. That was our approach. And then in construction management, the data that comes as a feedback gets consolidated, and we can calculate forecast data in order to adapt our production approach, the schedule, and how we want to do things. How does that look? That is our concept. The concept is basing on an idea by Jochen Teitzer. Basically, we use Bluetooth low energy beacons at each workstation. Then we have an app that we install on the smartphone of the workforce. And then we can sense what trade is in what room at what moment. And then we have also the possibility, because we update the data from the app to a cloud platform, to make that data available in order to inform all the workforces where the other workforces are as well, and what the current status is, and also KPIs can be calculated automatically, so that we have a self-regulating approach. The workforces can self-regulate them. That looks like that. We have the Bluetooth low energy beacons that are in each room, and those are referenced with the BIM model. And then we can also use sensors from other sources. For instance, we can attach some sensors to the head, and so we can combine certain information in order to calculate relevant KPIs. And those KPIs will be updated to the cloud platform, and afterwards we can visualize the information with Revit, and we can also update the process and rules and that kind of stuff with Dynamo. We tested that as well in an experimental setup with 4 trades. 2 days it took. It was inside. We simulated interior finishing task with a tech planning simulation game, and we had basically 3 rounds: conventional, normal, and optimized, and compared that with ground truth comparison as well, using manual nodes. And then we found out that in using that system, that app, the trades optimized themselves quite a bit. So the production time improved. Also, the travel time improved, and we even simulated certain problems. For instance, we closed the door, or we switched off the light in order to simulate those obstacles. And what was very interesting is that the data showed us instantly that there's a problem. We saw it instantly on the app, and also the trade saw it on the app, and that guaranteed us that we have a near real-time awareness of problems. So in future, we want to collect and analyze more data about it. We want to search alternatives for those beacons, the Bluetooth low energy beacons. And of course, we need to train the workforce and also the management how to use that technology. And then we can simulate it with other simulation games, and hopefully improve that approach. Further information about that approach and our proposal will be presented at the ISAC in Berlin. Jochen asked me to inform you about that, to advertise for it. So please make sure you find time for this interesting conference there as well. Thank you very much.
Questions?
Hello, Professor Margianis from Greece. I have attended sort of your presentation. And the question is, how you can utilize those data in terms of an application? You can warn somebody that he's wasting a lot, something more complicated than recording the data.
Basically, at first you just get data. Of course, you need to have a look what kind of work the person does, and then you have to match it. And then with time, you learn how to use that data and whether you can do something with it, what conclusions you can draw from it. But you have to learn that, obviously. And of course, there are also problems with privacy and stuff like that that have to be solved as well. Yeah.
No questions?
Thank you for presentation. So I have a question about, first, you're using, in fact, the phones as a gateways, so for collecting data. Are those phones are also mobile in the project? I mean, that you want to see the movement of the people?
Yeah, sure. The smartphones are at the worker. And once they change a room, they get connected to a different beacon, and that's how we update the information. So the smartphone stays with the worker.
Okay,
and the worker can use it to see the data as well, the updated data. There's an app on each smartphone.
Okay, and also you use for the beam integration part, you use Revit. Are you using the free APIs or?
Free APIs.
Okay, thank you.
Here is from the Technion in Israel. Actually, I'm doing, in my case, it's quite a similar thing. The question I have, you say the worker carries his smartphone and there's a beacon in each room, but how can you know if he's doing a task, like flooring or anything, or just standing in the room doing nothing?
Of course, that is always a problem. You have to trust the worker. But I think it is very important to trust the worker. When you use last planner and stuff like that, you use the knowledge of the workers as well. So we want them to act self-independent. But what our app allows us is make information available to them, so they can optimize their own work. They see where the other trades are, they see how effective they were themselves, and that's always good for them, for the companies themselves. They want to improve. So we think that is the right way to do it. We can't force it. And we can't see whether they are sleeping or doing anything else.
Just a follow-up quick question. Do you have a platform made for the management, or it's just the app carried with
the app is you can install it on a computer or a smartphone, and the management and the workers have the same information so far.
So there was a slide about the app and the production planning, how it's kind of integrated. Can you please?
This one?
No, the one before the technical side.
This one?
Yeah. So just want to know what's the kind of, how do you connect? You have the construction schedule there, and then the BIM, and then you have the process. I just want to know what's the kind of how do you achieve that integration and what kind of systems you're using for those three?
Okay, at the moment our approach is only from the smartphone back to the system. So it's not that we have to blend data on the mobile phone, not so much at least. There we have to rely on different technologies, for instance, a desktop somewhere in the construction site where the worker draw the information.
Okay, so that's like an existing planning system that is there.
Yeah, it's conventional at the moment.
questions? Okay, thank you very much, Jacob.
Thank you.
And so we're done with this session, so you still have time to go to other sessions.